Welcome to the AWS booth and the theater in our booth this year. You know, manufacturers for many years have been working on improving asset availability and reliability through a variety of different technologies, be it condition-based monitoring to predictive maintenance. But today we're going to talk about how customers are taking that one step further and integrating generative AI as a way to automate those maintenance workflows. My name is Joe Rosing. I'm the worldwide head of smart manufacturing at AWS. And again, today we're gonna first start by thinking about our overall digital manufacturing strategy and the role that maintenance strategy plays in that, and then start to talk through some examples of how we're seeing customers integrate generative AI into these workflows. Now, when customers start talking with me about manufacturing strategy, I'll oftentimes get asked, what are the trends? What's changing? How do I adapt to the change? It seems like every other week there's a LinkedIn post of a new LLM that's out there. What does this mean to me? And I like to take a step back and I actually reflect on something that our founder, Jeff Bezos, would say when he was founding Amazon.com in the retail business and would get asked a similar question. What are the changing trends that you're building Amazon.com on? And his comment is actually, when I build strategy, I'm not going to build it on the things that change. I'm going to build on the things that don't change. I'm going to focus on what are the durable needs of my customer, because that's how I'm going to think long-term about our strategy. And I think that's key to come back to when we think about technology and specifically generative AI. It is a space that is developing and growing very rapidly, changing very rapidly, and we can't pivot our strategy every week based on a new model or a new technology that comes out. So I think it's important that we go back to the fundamentals of good manufacturing strategy and how that applies to maintenance. And first and foremost is think about how can we apply technology to further reduce variation? How do I become predictably boring on my key performance indicators to make sure that I have good process control and make sure that I'm reducing variation in the process by way of obviously keeping the machines up and running and reliable? The second foundational piece is how do I empower employees? Especially in a discrete manufacturing setting, or if you have a Toyota production system, base production system, lean manufacturing. For years, we've been talking about how do we empower employees? How do we help put the power in the operator's fingertips to make the right decisions? And really the overall goal of any AI/ML use case is taking data to derive insights and helping our employees make better decisions faster. So that remains a key part of our objective when we think about maintenance strategy and manufacturing strategy. And then lastly, speed wins. In manufacturing, it's all about capacity optimization. And as technologies change, it's important that we're able to, one, maintain business continuity, but two, also make those changes and make those continuous improvements at the speed of business. And so it's important that we can experiment quickly, fail quickly, learn quickly, and then get the improvement in place and sustain those results. Every time I talk about generative AI, I also take a step back and think, what is the overall problem statement? And we got this stat from LNS Research, which I hear validated by my customers consistently as a concern that kind of keeps leaders up at night. And that's really around the skills and the knowledge gap. So one is losing employees or not being able to hire employees for the open recs that I have. But then two, having the skills, having the experience to know what to do to fix problems. And this is particularly important in the realm of maintenance because a lot of our maintenance technicians, the way they got good at their job and the way that they're maintaining the equipment today is based on 20 years of experience. They're that machine whisperer. They can hear how the machine is vibrating. They can hear that rattle noise, and they have some idea of what's happening. But a new technician fresh out of college doesn't have that experience. And unfortunately, for a lot of us, this is becoming the reality today of how do we better enable these newer technicians to, again, maintain the equipment at the same level of availability and reliability that the experienced technicians have. And if you look at this data, this highlights just the difference between basically pre-COVID and post-COVID. And look at the dynamics of our workforce, where the average tenure that we've had in manufacturing, these are global averages, has gone from 20 years down to 3 years. The average time in position has gone from 7 years to only 9 months. And then we see 3-month retention rates as low as 50%. This is why it's a top-of-mind concern for a lot of executives that we speak with, is how do I help, when I think about empowering that employee and reducing variation, how do I do that in a world where my workforce may be turning over every three months? and where I have technicians that maybe have only been in the job for less than a year. And that's a key area where generative AI can now play a role, because we can leverage a knowledge base, we can capture the tribal knowledge of those experienced technicians, and we can put it in the fingertips of those newer employees and make them more effective faster. Now I'm going to go through a couple customer examples, but I think it's important to note, like in the case of Kone, that they didn't achieve generative AI in their maintenance process overnight. In fact, this has been a journey oftentimes for a few years. And what we find is it's no coincidence that a lot of our generative AI customers, or a lot of our customers that are being very successful with generative AI today, started with IoT implementations or AI/ML implementations years ago. They already started the journey of connecting their equipment and started the journey of building an industrial data strategy that allowed them to have the tools and the arsenal of data that they needed to go deploy chatbots or other types of agent automations. And so Kone started a number of years ago with an IoT project where through connected elevators, they looked at reducing the number of customer issues and got to a point they could reduce those by 40% because they were getting insights into and trend data of when the elevator was looking like it was potentially going to fail. And then they were able to proactively address those faults 70% of the time. So they already were making great strides in improving the availability and reliability of their elevators, of their products, in this case, out in the field, by just having connected equipment and getting some of those insights. But then they started rethinking or kind of leveling up on what their current problem statement is. And this was presented at our reInvent show in November, where they said, let's look across the world. We have 1.6 million units that are maintained by our teams. There's about 2 billion people per day that are using Kone elevators or Kone products, and that equates to about 600,000 customers worldwide. So the scope is such that even a connected elevator, and I have all this data, like how do I drive improvements and how to drive that continuous improvement at this type of scale becomes another problem. They also, when they think about their field service teams of how they're going to service that, they have over 60,000 employees in about 40 different countries. They're making 100,000 maintenance visits per day. And what becomes really important is there are over 1,000 different types of machines or 1,000 different types of equipment that they have to maintain. Their ethos is when their field service techs show up at a site that they're going to maintain the health of the whole elevator. And so they look at all of the parts, not just a handful or a subset of what the main items are. And if you think about having a knowledge worker that knows how to maintain 1,000 different pieces of equipment, there's no way that one person can be an expert on that many different things. And so their overall challenge was, one, that diverse maintenance product mix. So how do I help my team be experts on that many different pieces of equipment? And then two, just this technician generation shift. So they were feeling the pain of those stats I presented earlier, where a lot of their technicians were newer, they didn't have the 20 plus years of experience, and that generational shift also meant that they were expecting a more technology-based interface. They were oftentimes expecting to be able to have a phone or a mobile device or a tablet that they could interact with to help guide them through the process. And the old way of doing things is the field technician would go out on site, and if they came across one of those pieces of equipment, one of those pieces of 1,000 equipment, and they didn't know what to do, the answer was phone a friend. They had a hotline that they would call, and there'd be somebody sitting at a help desk, and the technician may have to wait even up to 30 minutes to get a hold of somebody at that help desk. And then when they got a hold of somebody, they were going through paper manuals to help them sort out and troubleshoot the process. And it could take a long period of time. And so what Kone did is they worked with us to build basically a generative AI-based application that the technicians in the field could use as a way to automate that entire process. And so instead of phoning a friend and going through the manuals, they uploaded those manuals into their AWS environment, and then we were able to use generative AI and different querying abilities to go search through all those manuals, and they took the troubleshooting time down to minutes. So what was oftentimes taking hours in this very manual phone process, they could make happen very quickly and put the answers in the fingertips of their employees. And so again, I think back to those foundational elements of what's not changing. We want to reduce variation, right? Now, regardless of who's on the other end of that phone, doesn't matter. Because I've automated that process, and the answers I'm giving to my field service technician are always the same. I've reduced variation in the guidance I'm providing. I'm also empowering my employee. I'm empowering that technician because they have all those answers right at their fingertips, and I'm helping that person move at the speed of business because they're able to troubleshoot again in a matter of minutes as opposed to hours. Now, while that's a field service example, obviously we also do maintenance inside the four walls of the factory. And so another example is with Georgia Pacific. And again, we started working with Georgia Pacific 7 years ago on predictive maintenance and helping them predict paper tears as a failure mode up to 90 days in advance. And so there's already a lot of work we are doing on their paper machines around collecting data and the right inputs off the machine and modeling and starting to predict when we'd run into failures. But they also were struggling with this generational shift with their technicians, and again, wanted to empower their employees to troubleshoot the variety of different things that could go wrong on the equipment. And so again, it was more of a chatbot type RAG-based model that they started with as a way to help their technicians be able to query, hey, I see these different error codes. What do they mean? What do they have in common? The last time I saw these error codes, what did the technician do to fix the issue? What spare parts would I need? How did I bring the machine back up? So it was querying a variety of different troubleshooting guides, maintenance record history, ERP system data, as a way to, again, quickly put the power in the fingertips of their technicians to get the equipment up and running much faster. And you can see on the right side how they also were able to take, through this troubleshooting guidance, take the downtimes down drastically to a matter of minutes because they were able to troubleshoot the issues much faster. Now, before we go into some examples of how these customers have taken their chatbots to another level by integrating agents and automating some of those workflows, let me walk through the process that we use as a way to help customers think about the role that agents and automation can have when extending these use cases with generative AI. So when we think about building intelligent workflow automation, there's actually 3 different categories that I think about. The first is these deterministic business workflows. And if we think about an example that maybe we're all familiar with, think about booking a trip. So if I'm trying to automate a deterministic business workflow, that's just me booking a trip with the lowest cost. I decided that my main objective or my main goal is cost. I want to fly back to the US with the lowest airfare. So I can easily search that and optimize for cost. But then if I think about an agentic application, I'm thinking, how do I handle this in a more dynamic manner? And so if I'm booking that trip, I then may think about, okay, I'm booking the trip, I want the lowest cost, but I also want to think about the different preferences. I'm a United guy, Star Alliance. So if the cheapest flight is on Ryanair, okay, that's nice, but what's the cheapest United flight? Where am I going to get more miles? Where is it going to help contribute to my status? Where do I have more seat availability options? I like to sit in the aisle. Are there only middle seats available, right? So dynamically, I want to understand some of those different variables that I might want to take into account. And that's where we want to have agents that can start to then look at those different things. And if I add one layer of complexity on top of that, it's this multiple agent collaboration. So how do I pull all those different dynamics together? And in this case, I might want to look at the entire itinerary. So I can't fly home to Seattle maybe on a direct flight. So what are all the different connection points that I might have? And in this case, I might have to have multiple agents start to run different optimizations for lowest cost, where I have the preference of my airline, where I have seat availability, where I have the lowest layover, right? So different combinations of things that come together. Now, if we think about that example, but in the context of manufacturing and maintenance, think about first, in the first case, when I have deterministic rules-based workflows, I'm just going to schedule that maintenance work order based on an alarm. I get an alarm that says something is wrong with the equipment, go create a work order, okay? But then in the second case, I might want to not only create that work order, but I want to take into account who will I assign to that work order? What technician is most available? What technician has the right skill set to go do this particular issue or work on this particular machine? And then again, if I add a little bit more complexity and think about multiple agents, this is now graduating. If I have predictive maintenance, but also prescriptive maintenance, I want to know not only what technician I send there, but how should I advise that technician to fix the problem? What spare parts should they bring? How much does that spare part cost? How long is it going to take for them to get this done? Am I optimizing for just getting the machine up and running? Or is this something that I should schedule a planned downtime window for in the future? So adding these different complex dynamics, that's really where the role of multiple agents comes to play, so that I can start to look at multiple things in parallel to make the optimal decision. Another way to think about this is breaking down these human-in-the-loop workflows. And the example that is easy to think about in this sense is autonomous driving. So if you think about building an autonomous vehicle and the software involved in that, you first start with what is the goal. The overall goal of autonomous driving, or anytime I get in the car, is to get to my destination. If I can't get to the destination I want, then what was the point in the first place, right? That's my main objective. And then there's secondary goals that I also want to keep in mind. So for example, I want to get there safely. I want to get there in the shortest amount of time, or I want to get there with the most fuel efficiency. There might be different goals that I want to be optimizing for. Once I decide what those goals are, then I think about the different scenarios that I'm going to have to address when I automate those workflows without a human in the loop. So scenarios might be, I'm going to approach a curved road. I might have to do something differently if I'm going to approach a curved road. It might be rush hour traffic. I might need to go on the freeway. So I somehow need to diagnose these different scenarios, because that's going to dictate maybe some different decisions that I'm going to make to achieve my goal of getting to my destination. And then the final thing I think about is, what are the skills I need to address those scenarios? So those skills might be, I need to merge into traffic. It might be I need to pass another car, or I need to stay in the lane. And I build out what those different skills are so that I have the flexibility to pull up those different skills and execute them based on the scenario that I decide. And then ultimately, what we do when we build this autonomous AI model is we think about the overall action loop. And what the action loop does is I first sense, what is my scenario? And then I plan, what skills do I need to execute against my goal in this scenario? And then I go act, and I go do that scenario. So this is where multiple different capabilities and technologies come together. Because how I determine what scenario I'm in might be a status of condition-based monitoring. It might be determined by a predictive maintenance model. It might be determined by computer vision. There are different ways that I can determine what scenario I'm in. And then once I determine that scenario, how I pick the right skill to go execute that task autonomously becomes another way that I employ the model. And so a key part of these multi-agent workflows is thinking about how we orchestrate this triangle and how we bring together our overall objective with I'll say the sub-goals, like in this case, safety and efficiency, and then how I build the right optimizations to say, okay, this is the decision path based on this continuous loop of understanding what scenario that I'm in. Now, to make it a little bit more concrete for manufacturing, let's look at an example that one of the partners in our booth, Tri-Diagonal Solutions, has built. And in this case, what they wanted to do is rethink the computerized maintenance management system, rethink what a CMS does. I don't want to just create a maintenance work order. If there's a way that I can use agents to create it more intelligently and, again, empower my employees and reduce variation and move at the speed of business. And so in the old process, what would happen is a machine operator might say, I see a problem. There's a leak. There's a leak at the flange. Let me call the maintenance technician, or let me submit an issue. Let me submit a ticket. And they submit that ticket, and then somehow whoever the technician is that's available comes to the line. And what happens? They find the operator. Who logged this down? Okay, what was the issue? What machine are we on? Okay, let me look at it. Were there any error codes that were happening? What spare part would I need? I didn't bring it with me. I brought the wrong set of tools. Let me go back to the tool crib and get what I need. And then I come back later again, right? Meanwhile, the machine's not running, right? We're downtime. And so how do I accelerate my ability to get the machine back up and running again? How do I empower my technician to fix it right the first time that they get to the line? And so in this case, as we rethink that maintenance workflow, we still enable the operator with natural language to submit what the problem is. They've entered the problem in that text box. I see this leak, okay? But instead of just leaving at that and waiting for the technician to come to manually diagnose the problem, we've put multiple agents out to go pre-populate things in the maintenance work order. So based on where the issue was logged down, I can pull up and see what equipment I'm on, what asset it is, and I can load that up into the work order. I can also then look in the maintenance history and say the last time that I've seen a leak on this flange, it's typically been an issue related to the gasket. And it's been solved by bringing out a gasket kit. So that agent has gone into the maintenance records to prescribe what to go do to fix the issue. And then on top of that, I want to understand what would the overall cost of fixing this issue be? Well, I can go into the ERP system and have an agent go pick up how much does that gasket kit cost and put it in the maintenance work order. And now if I'm a maintenance technician, what's going to happen is I'm going to go through my list of tasks for the day. Now, sometimes these tasks might be cycle-based. Hey, it's been 3 months, go change a filter. Sometimes they're predictive maintenance based. There still might be a predictive maintenance model in place that says, hey, we're predicting a failure in 60 days. It might be time to go look at this, right? But sometimes now they're going to be these maintenance work orders that came up in the moment from the operator. And they've already been prioritized because of the agent that has been put in place to pre-prioritize that work order and prescribe what you need to go do for it. And so now as a technician, I don't have to worry about going out to the line and figuring out what the issue is and taking time to diagnose it before I go figure out how I'm going to solve it. I can go out to the line fully empowered with, I know I got to bring a gasket kit with me, I know what machine it is, I know the person that logged it down, and I can get this machine back up and running much faster, okay? And again, I go back to those fundamentals. What have I done here? I've reduced the variation in how I get the machine back up and running. Right? I've empowered my employee, empowered my technician to get it fixed right the first time, and I'm moving at the speed of business. Now, one other thing to show that we can do with the agent, let's see if this runs, is also provide a dashboard that allows us to have visibility of all the issues that might be out there on the shop floor. And in this case, you're seeing Amazon QuickSight, which we've enabled Q for QuickSight into. And what Q is doing is it gives you the ability to use generative AI to adapt the dashboard as you need it. So there's no more looking at a dashboard from an analyst and saying, yeah, this is good, but I don't really like to see it in columns. I want to see it in lines. Or I don't quite have the answer that I need because I want to see who are all of the technicians that are already occupied today and who might be available to do the next task. And so what I can do is use Q to just ask that question, and QuickSight will automatically create that visibility for me in real time. And so they've also built in, Tridiagonal in this case has integrated Amazon QuickSight into the solution as a way to have that business intelligence or visibility into the overall maintenance plan and the technicians and what they're executing in the workflow. Now the last example that I'll walk through, see if this plays, yeah. Is another example of where we're using generative AI as a way to rethink manufacturing processes. In this case, we're rethinking the production meeting. And so you'll see kind of a number of things that walk through the different parts of the dashboard. But again, I go back to some of my days in the plants where I always wanted to run a production meeting that was actionable. I wanted my team to show up, ready to take action to go fix the issue of the day. What I didn't want to do is have a 30-minute meeting debating, okay, do we have all the data? What did we build yesterday? What were the issues yesterday? Oh, why does your data look different than my data? Who ran this spreadsheet, right? Where did this pivot table come from? So instead, what we've done is we've enabled the production meeting with generative AI and through Amazon QuickSight as a way to automatically create a standard data set that allows everyone to show up to the meeting with the same understanding of the status of production. I have one customer that they do their production meeting every day at 8:30 a.m. Their team comes in at 7 a.m. every morning. They spend the first 90 minutes of their day extracting data and putting it into a pivot table to get ready for the production meeting. And we showed him this, and he's like, oh my God, that would save 90 minutes a day of some of my most talented employees. And now, again, we can show up to the meeting all with the same understanding of what happened yesterday, so we can only focus on what we need to do today, who does what by when to go fix the issues, and get production running optimally again. Specific to maintenance, there's a dashboard or a specific tab on here that we can use to just give me a summary of, hey, what were all the maintenance issues of the day yesterday? As well as say, hey, what are all the planned downtimes in the next week? What are the lines that have error codes showing on them this morning that still need to be addressed? What are the technicians that haven't been assigned to a maintenance work order yet today? And I can query all of that information. So instead of asking somebody in the meeting, hoping that they have brought the data with them or waiting for them to go retrieve that information, I have it at my fingertips. And again, we can talk about who's going to do what by when to get us up and running again. Now, in the last 5 minutes, I just want to highlight a couple AWS capabilities of things that we have available and we have on display in the booth today that's making all of this easier for our customers to put together. Because we can understand that, as we think about that autonomous AI triangle, there's a lot going on there, right? And ideally, you're also combining a lot of different capabilities, again, between condition-based monitoring, predictive models, different LLMs. And so there's different capabilities that AWS has available to make this easier. And first, let's think about Amazon Bedrock agents. And it's really set up in that same workflow. We think about first, how do we decompose the problem into steps? And then look at the different actions or how we would search a knowledge base to go execute those steps. And then there's a process that you'd follow as you start to train these models. So you start to build what is the workflow, the steps you'd go through, observe the results, and then based on those results, okay, now what is the next step that I would take? And ultimately get to that final answer. When I do this with customers, I'll oftentimes say, hey, if there's a manual process where the maintenance technician is troubleshooting it today, when there's an issue, call me to the line. Because I just want to follow the maintenance technician. I want to understand what is their troubleshooting process. And I just watch. What are the manuals that they open up? What are they tweaking on the machine? What are they looking at on the piece of equipment on the line or on the part on the line? Because those are all things that help us to decompose the problem and then think about, okay, where do I have data somewhere in my environment that I can pump into this problem statement and start to automate that troubleshooting process? And that's really the next part of Bedrock Agents, is then thinking through, one, picking a foundation model that matches the use case that I'm working on, but then two, providing it basic instructions based on how I've decomposed that process of that troubleshooting workflow, and then where is that data coming from? So again, we never approach these problems as, let's just connect everything and we'll figure out what to do with the data later, right? We're working backwards in the sense of, once we figure out what is that troubleshooting process, what is that technician looking at, then where do I have access to that data today? Is it in the right frequency, the right fidelity to get the outcome that I want? And if not, that becomes a very data-driven problem statement for me to go solve from an IoT perspective. The other thing that AWS offers is Amazon Bedrock Flows, which gives a visual interface, if you will, of how these flows come together. So as I start to build out those steps, it doesn't help me if it's all just a bunch of code, right? This gives me a visual interface to start to mix and match how the different components are coming together, and gives me the ability to have a lot of flexibility in terms of how I scale this and how I might test it in a way that is safe and non-disruptive for the production environment. And so AWS brings a number of different technologies to bear to help you execute generative AI faster and with the right price performance. And so if we look at this overall generative AI stack, we can start at the bottom, where it's all about the infrastructure that you need to achieve the price performance that allows you to execute generative AI into production. And this is everything from using things like Amazon SageMaker down to the chips that we have available, such as Trainium and Inferentia and some of the GPUs, to, again, help you achieve the price performance that you need, such that you can get an ROI when you execute these use cases in production. And then Amazon Bedrock is really our tool that gives you API access into a number of different LLMs and foundation models. And this is really important because models are built for different reasons, right? And it gives you the ability then to experiment with which model is going to give you the best outcome of the result for your use case. Which one is going to give it to you in the speed that you need? Which one gives it to you in the better format that you need? Which one just gives you the more accurate answer? And it's very common as well that we start to orchestrate multiple LLMs to ultimately get the outcome that you want. So all of that is available at your fingertips through Amazon Bedrock and the different LLMs that are available by API in Bedrock. And then at the application layer, we have Amazon Q. You saw an example of that a little bit in the video by way of QuickSight Q, where Q is basically your human to machine learning interface. You could almost think of it that way. It's essentially your ability to chat or query very quickly into your knowledge base, and the ability to do that both with business applications as well as through Q developers' ability to help you write code faster for different applications or different types of use cases. So to wrap things up, I got 1 minute left. When we talk about getting started with generative AI, it's still important to pick the right use case. And in particular with these maintenance use cases, one thing I always advise my customers on is don't pick that old piece of equipment in the corner that's not a constraint machine. You'll never get an ROI on it, right? We want to work on something that's going to have a financial impact to your plant. So let's understand what is the piece of equipment that is your most gating piece of equipment. What is the bottleneck? Where is the constraint? And then as we look in that piece of equipment, we'll understand what are the failure modes? What is the maintenance process today? How do you address issues today? Is it all done through preventive maintenance? Is there any condition-based monitoring? Have you thought about predictive modeling? Right, we'll work through that process because it's a journey. We're not going to implement generative AI overnight, but as we understand your workflow and your maintenance process, that allows us to ultimately get to the point of thinking about how we can deploy autonomous AI and generative AI to automate these maintenance workflows and ultimately empower your teams with some of these new innovative tools to help improve machine availability and reliability. And so with that, I'll wrap it up. Again, Tri-Diagonal, the solution that you saw here is in our booth, as well as a number of other partners that are working on autonomous AI and generative AI capabilities. Composable, that has that triangle framework, is at the Rockwell Automation kiosk. And then there's a number of demos just outside here to the left that are showing some of our different generative AI capabilities with the Nova models as well as the SiteWise Assistant. So I'll be up on stage for another few minutes if you have any questions. But thank you for your time today, and thank you for joining us in the AWS booth at Hannover Messe.